frequencies, right? For analyzing frequencies. So in this chi-square test, what we are going to do is that we are going to take the observed frequency and we are going to calculate the expected frequencies on the basis of some null hypothesis. And then we are going to compare two frequencies, right? So the observed frequencies are those which we have taken out of our experiment or out of our sampling procedure. And the expected frequencies are those which we have to calculate ourselves. And how we are going to calculate these expected frequencies? We are going to calculate them on the basis of some null hypothesis. And then we compare the observed and the expected frequency. And this comparison is the chi-square test. And this is the formula for the chi-square test. And this symbol, right, this letter is chi. So this is chi-square. And then how chi-square is calculated by this factor. So as you can see that this is summation sign here, right? So this is sum of this factor. That first we have to take the O refers to the observed frequencies and E refers to the expected frequencies. So first we have to take the difference of the observed and expected frequencies. Then we have to take the square of that difference, and then we have to divide that square of the difference between observed and expected frequencies by the frequency. And we will do that for all the classes, for all the observations, and then the sum of this factor, all of the observations, will be the chi-square value. So we have different types of the chi-square test. The three basic types of the chi-square tests are the test of homogeneity, goodness of fit test, and the chi-square test of independence. So these are the three basic types that we are going to study. And all of these three types, they follow a general formula is same for all of these three types, right? But the procedure of calculating the expected frequencies is in all three of them. So the general procedure is that you have to choose the type of the chi-square test, that what type of chi-square test is suitable for your data. And then you have to formulate a null and alternative hypothesis. And then you have to calculate the expected frequencies on the basis of the null hypothesis that you have made, right? And then you have to do the calculations. And the calculations are simple, that you have to take the difference of the observed and expected frequencies, to take the square and divide it by E, do it for all the classes, for all the frequency classes, and then take their sum. And in the next step, when we have to give our conclusion, or when we is the test statistic, and we're going to compare it with the calculated value of chi-square, this calculated value of chi-square with the table value. And we can get this table value from the chi-square distribution table. And on the basis of this comparison, we're going to either accept or reject the null hypothesis, and we are going to state our results. So general procedure, right? That we have to choose the type of the chi-square test, and we have to state our hypothesis. We have to calculate the expected frequencies, and then we have to do the calculation. And when we get the calculated value, we have to compare it with the table value, and then we are going to state the results. So starting from the chi-square test of homogeneity, right? And the chi-square test of homogeneity, as you can see from the name, this is the test for homogeneous frequencies, right? So homogeneous frequencies are those in which the classes, all of the classes, they have equal frequencies, right? So they have similar frequencies. So our assumption is that frequency distribution is uniform in all classes or categories, right? So this is our assumption, that in the chi-square test of homogeneity, where we are going to apply this test, when we assume, or when we suppose, that the frequency distribution is uniform in all classes or categories. It means that all of the classes and categories that we have, they all have similar frequency. There is no difference in their frequency distribution, or there is no significant difference in their frequency distribution. So this is a type of a condition in which we have to do the chi-square test of homogeneity. to check that whether this distribution is homogeneous or no. And for that purpose, we are going to take example of the Dixella pupae, and a biologist collects a sample of Dixella pupae from a pond. And these pupae, they emerge out in following numbers. So Dixella autumnalis, 24, then Dixella estivalis, 32, Dixella amphibia, 10, and Dixella erica, 9. So the biologist collected a total of 75 pupae, right? And out of these 75 pupae, the 4 species of Dixella emerged in these numbers, right? So these are their frequencies. The frequency of Dixella autumnalis is 24, the frequency of Dixella estivalis is 32, frequency of Dixella amphibia is, and frequency of Dixella erica is 9. So unless and until you have an idea about their distribution, what do you have to suppose? Anyone? Unless and
Ma'am,
until you know that there is a specific species composition, then what are you going to suppose?
ma'am, homogeneous frequencies है.
Yes, unless and until you have an idea, unless and until you have a previous report or record of their species composition, that what is the percentage of which species in the pond, right? So unless and until you have this idea, you have to suppose that this frequency should be homogeneous. So do you think this is homogeneous?
No, ma'am.
Homogeneous means same, right? So is this frequency same or nearly similar?
No, ma'am.
No, ma'am.
Yes, so apparently it seems that these frequencies are very much different from each other, right? Like the lowest frequency is 9 and the highest frequency is 32, and there's a lot of difference between 9 and 32. But again, we have to talk in terms of the statistics, and we need to figure out whether this difference is by chance, this difference is by sampling error, by chance, or this difference is significant. Significant means that this difference is actually present. So what kind of the test we have to apply? We have to apply the chi-square test of homogeneity. Why we are applying the chi-square test of homogeneity? Because we want to check that whether the distribution frequencies between the categories homogeneous or no. And why we are considering them homogeneous? Because either we don't have a previous record, right, or the distribution is uniform. So there can be two possibilities: either the distribution is uniform, or we don't have any previous record, previous information about the species composition. So therefore we are going to chi-square test of homogeneity, and we are going to check that these differences that we see in these sizes, in these frequencies, whether these differences are significant or no. So is this point clear? That what is the basis of this test?
Yes, ma'am.
Yes, ma'am.
Okay. So we are going to apply the test of homogeneity. So we are going to test for the homogeneous frequency. Right, so we are going to use the chi-square test of homogeneity. So if you remember the general procedure, what was the first step that you have to check to type of the chi-square test? And what is the next step? What is the second step? That you have to state the null and alternative hypothesis. So we have chosen our test that we are going to apply the chi-square test of homogeneity. Now we are going to state the null and alternative hypothesis. So the null hypothesis, the observed frequencies are homogeneous and the departure is merely due to sampling error or scatter, right? We are supposing here that the observed frequencies are actually homogeneous, and this departure from what? Departure from homogeneity is due to sampling error or scatter. So this difference, in simple words, we can say the frequencies of these species in the pond are homogeneous, and the difference that we see in our sampling is because of the sampling error, or it is because of chance. So this is our null hypothesis, right? So in the null hypothesis, we have assumed that there is no difference between the frequencies. And we have to state the alternative hypothesis as well. And the alternative hypothesis would be that there is a difference, right? The observed frequencies depart from those expected of this distribution by an amount that cannot be explained by sampling error. In simple words, we can say is a significant difference between the observed frequencies, right? There is a significant difference between frequencies and they cannot be considered homogeneous. So the frequencies that we have observed, they depart from the expected frequency, right? And what is the expected frequency? The frequency is expected from a homogeneous distribution. And how much they depart? They depart to an extent that can be attributed to sampling error alone, right? That we cannot put this onto the sampling error. Rather, we have to admit that this is the significant difference that is actually present in the pond. So these are the hypotheses. Any questions?
मैम आपने ये लास्ट में जो पॉइंट बताया है कि अगर ये जो डिपार्ट हुई हैं फ्रिक्वेंसीज उस एक्सटेंट तक कि वो सिग्निफिकेंट डिफरेंस की वजह से हुई हैं या फिर सैम्पलिंग एरर की वजह से हुई हैं?
जो अल्टरनेटिव हाइपोथेसिस में
यस मैम.
So in the alternative hypothesis, the difference is that big. We are supposing the difference is that big that we cannot attribute this difference only to the sampling error. That we cannot blame sampling error for this difference. Rather, this difference is significant. This difference is a huge one, right? That cannot be explained by error. So the amount of the difference that we see between the observed frequencies and the expected frequencies for a homogeneous distribution. So this difference is that huge that we cannot explain this with the help of the sampling error. In other words, we can say that sampling error alone is not responsible. And in the null hypothesis, we had stated that this difference that we see, this difference is because of sampling error. It's not because of the differences in their species composition or differences in their distribution in the pond, right? So in the null hypothesis, we are assuming that this difference is non-significant and this difference is because of sampling error. And in alternative hypothesis, we are saying that this difference is not just because of the sampling error, rather it is actually present in the pond. It is actually present in the population. And in other words, we can say here that the observed frequency that the null hypothesis is that observed frequency is equal to expected frequency, right? Equal to means that this is non-significantly different from the frequency. And here we can say that the observed frequency is not equal to the expected frequency. Not equal to the expected frequency means that this is different from the expected frequency and this difference is significant. As we can see that our observed frequencies are actually different, right? So you can see that observed frequencies, they are not similar to each other, rather we see the difference, right? So in the null hypothesis, we suppose that this difference is because of the sampling error, this difference is by chance, right? So therefore this difference is to be considered non-significant. While in alternative hypothesis, we suppose that this difference, right, is actually significant, right? And this cannot be attributed to sampling error alone. So this is our null and hypothesis, and this is our hypothesis. Now, what is the next step? The next step is to calculate the expected frequencies. And how are we going to calculate the expected frequencies? We just discussed in the general procedure.
मैम एक्स स्क्वायर चाई स्क्वायर वाले फॉर्मूले से काई स्क्वायर सॉरी
No. Expected frequencies. Chi-square तो हम बाद में apply करेंगे ना formula. First, we need to have the expected frequencies for all these 4 classes.
By the basis of null hypothesis.
Yes, on the basis of null hypothesis, right? So expected frequencies are to be calculated on the basis of null hypothesis. And what is our null hypothesis here?
That observed frequencies are equal to expected one.
Yes, the observed frequencies are equal to expected frequencies. It means that the expected frequencies should be same in all of the classes. So for that purpose, what we are going to do is that we are going to calculate the homogeneous expected frequencies from the total number of observations that we have. So what is the total number of pupae that collected? There were 75, right? So 75 has to be homogeneously distributed into 4 classes, right? So the 75 has to be distributed equally or uniformly or homogeneously into 4 classes. So this is going to be 75 by 4, right? 1 by 4 into 75 or 75 by 4. This is going to be 18.75. So the expected frequency is 18.75 for each of the species. Do you get this point?
Yes, ma'am.
मैम इसको एक दफा बता दें फिर
Okay, so what we have to do is that we have to calculate the expected frequencies, right? Because the chi-square is the comparison of observed and expected frequencies. So we only have frequencies. We have to calculate the expected frequency. And how do we calculate the expected frequencies? We calculate the expected frequencies on the basis of the null hypothesis that we have proposed, right? And we have proposed the null hypothesis that the observed frequencies are equal to expected frequencies, right? And null hypothesis states that the expected frequencies are homogeneous among different classes, right? The observed frequencies are homogeneous. As you can see here, the observed frequencies are homogeneous and is due to sampling error. So homogeneous means that this total number is 75. So what is our total number of observations? We have 75, right? So this 75 must be equally distributed into the 4 classes if the frequencies are homogeneous, right? So our null hypothesis is that frequencies are homogeneous, so the expected frequency should be homogeneous between the 4 classes. So we have to divide 75 by 4. So when we 75 by 4, we get 18.75, and each of the class is going to have the expected frequency of 18.75. So these are the observed frequencies and these are the expected frequencies. So 1 by 4 into 75 or 75 by 4. So this is the expected frequency. So the observed frequency for Dixella autumnalis is 24 and the expected frequency is 18.75. The frequency for Dixella aestivalis is 32 and the expected is 18.75. The observed frequency for Dixella amphibia is 10 and the expected is 18.75. And the observed for Dixella erica is 9 and the expected is 18.75. So this is the expected frequency. Now, is it clear now?
yes ma'am it's clear
Okay, so let me check the, okay. So if this point is clear that how you have calculated the expected frequencies, then let me tell you another important point, and that point is that because we are talking about the count, right? That the frequencies, that how many are Dixella autumnalis, how many are estivalis. So this is the count, 24, 30, 10, and 9. This is not something measurement. This is count. So naturally, we do round count values, right? So the count values, because there cannot be 18.75 pupae, there can be either 18 or 19, right? Because these are to be in the whole numbers. But because we are calculating this only for the calculation purpose, so therefore we are going to go with this fraction. We are not going to round it off. ठीक है, round off नहीं करना. Naturally, आप यही समझेंगे कि because this is count of thing, so this should be a whole number. So it can be rounded off to 19. No, because we have to use this only for the calculation purpose. So therefore, we keep this as such. So there is no need to round this off. Is this point clear?
Yes.
Yes, ma'am.
Okay. So now we are done with our third step, right? So the first step was to choose the type of the chi-square test. Second step to state the null and alternative hypothesis. Third step was to calculate the expected frequencies. And now we are at the third step, that we have to calculate the chi-square value. And for the chi-square value, we first have to calculate the difference between observed and expected frequency for each of these classes, right? So for the first class, for Dixella autumnalis, this is going to be 4, which is the observed frequency, minus 18.75, which is the expected frequency, right? So this difference is going to be 5.25. Or what we can do is, let me explain you the procedure here, and then you come up with the chi-square value yourself so that you can have the practice as well. So you have to calculate the observed, the difference between the observed and expected frequency for each class separately. Then you have to take the square of these individual values, and then you have to divide this square of the difference by the expected frequency of respective class. ठीक है, आपने जो डिक्सेला ऑटोमनेलिस है इसी की ऑब्जर्व्ड और फ्रीक्वेंसी का डिफरेंस लेना है, उसी डिफरेंस का आपने स्क्वायर लेना है, उसी स्क्वायर ऑफ डिफरेंस को आपने इसी की एक्सपेक्टेड से डिवाइड करना है. And you have to repeat this step for the rest of the 3 classes as well. And then you have to take sum of this column, and that sum is going to be your test statistic, which is the chi-square value. So you have these things. So just calculate the chi-square value and come up with the answer. Okay.
Excuse
And I
me,
think,
ma'am.
yes.
मैम ये राउंड ऑफ का आपने बताया था कि जो काउंट नंबर्स होते हैं उनको हम राउंड ऑफ नहीं करते, इसको एक दफा एक्सप्लेन कर दो.
हाँ जी, यही मैंने आपको बताया था कि जो काउंट होता है उसको तो हम नेचुरली राउंड ऑफ करते हैं ना, अगर हमने अपना रिजल्ट करना हो. लेकिन यहाँ पे हम रिजल्ट नहीं स्टेट कर रहे, वी आर जस्ट यूजिंग इट फॉर द कैलकुलेशन पर्पस. So in the calculation purpose, we have to use this as such. Because if we are going to round this off, this is going to create problem in the calculation, and we are not going to get actual chi-square value. So we have to keep this as such.
All right, ma'am.
मैम
जी
मैम हमने जब ऑब्जर्व्ड और एक्सपेक्टेड का डिफरेंस लेना है और फिर उसका स्क्वायर लेना है, तो वो तो पॉइंट्स में ही आएगा, तो उसको एज इट इज रखना है या उसको राउंड ऑफ करना है?
अब माइनस में आया डिफरेंस?
नो मैम.
मुझे आपकी आवाज में डिस्टॉर्शन है, तो मुझे समझ नहीं आ रहा क्या कह रही है. आपके पास चाहे ये प्लस में आता है चाहे माइनस में आता है, आपने उसको एज सच स्टेट, because in the next step you're going to take the square. So even if it is minus, this is going to become plus.
मैम इसकी वैल्यू आई है 19.96.
आपने कैलकुलेट कर लिए?
Yes, ma'am.
Okay, let's wait for the other and then we are going to see.
Ma'am, 19.8.98.
Have you done the calculations or do you need more time? Do you need more time?
No, ma'am.
Okay. So now you can tally your answers. So the difference between the observed and expected frequency for the first class is 5.25. Then for the next one, it is 30.25. Then it is minus 8.75. Then it is minus 9.75. So are these that you have calculated?
Yes, ma'am.
Yes, ma'am.
The next column is you have to take the square of this value. So 5.25 square of the 5.25 is 27.5625. And then for the next one, it is 175.5625. And so are these the same values?
Yes, ma'am.
ये भी ऐसी हैं आपके values?
Yes, ma'am.
Yes, ma'am.
Okay, now the final column is when you have to divide this square of the difference by the expected frequency of the same class, right? So these are the values. And this is the chi-square, 18.987. And what is chi-square? This is the sum of this column, right? Sum of this column, 1.47 plus 9.3633 plus 4.0833 plus 5.07. Sum of this column is the chi-square value. So is this the value that you have calculated?
Yes, ma'am.
Okay, so step we chose the type of the chi-square test, then we stated the hypothesis, statistic, which is the calculated value of chi-square. What should be the next step?
मैम टेबल से हम मैच करेंगे वैल्यूज.
Yes, we have to compare this value with the tabled value. Out the probability of null hypothesis to be true, right? So we are going towards the table. For the table, we need to know the degree of freedom. So degree of freedom in case of this test of homogeneity is n minus 1. And n in this case is the number of classes. So remember one thing, that n here in this test of homogeneity is not the number of observations. Number of observations are 75, right? Number of observations are 75, but this one is the number of classes. And how many are the classes?
4.
4 ma'am.
4.
4, right? So this should be 3. Degree of freedom here should be -1, which is 4 minus 1, 3. Okay, so now we have to find out the probability of null hypothesis to be true, and this was our null hypothesis, and we are going towards the chi-square distribution table. So here we have the chi-square distribution table. And previously you had seen the t distribution table, and this is the chi-square distribution table. And again, you can see that we have rows and columns. So in the columns, we have the probability, right? And in rows, we have the degree of freedom. So what is probability at which we need to check? 0.05 पे check करते हैं.
Yes, ma'am.
Yes, ma'am.
So, and what is the degree of freedom? Degree of freedom is 3.
3.
Right? So we have to check the value which lies at the probability of 0.05 and degree of freedom 3, and that value is 7.815. Right? So this value is 7.815. So the calculated value is 19.987. So this value is greater than the table value. So are we going to accept or reject the null hypothesis?
मैम 0.05
Reject.
करेंगे हम ये 0.05 में.
Yes, so we are going to reject the null hypothesis. So we are going to reject the null hypothesis in favor of alternative hypothesis. The significance level is 95%, which is significant. So we can say that these are significant, different from the homogeneous frequencies. So if this point is clear, then we can move on to the next one. Ye clear ho gaya?
Yes, sir.
Okay, so do you remember the different levels of significance? We defined 3 levels, right? The lowest one is significant, then we have significant, and then we have very highly significant. So at what point we decide for the highly significant result? हम highly significant value कहाँ पे decide करते हैं?
99%.
90% पे, which is 0.01,
1.
right? The significance is checked at the 0.05 level, and if the value is found to be significant at this level, then we need to check that whether it is significant at the upper levels as well or no. So the next level is 0.01, right? 0.01, and the value here is 11.345. See that our calculated value is greater than this value as well. Is value से भी बड़ी है, right?
Yes,
So
ma'am.
are we going to say that this is highly significant?
No, ma'am.
Because this value is greater than this value, so therefore it is significant at this point as well, right? So we have to say that this is highly significant. At the significance level of 99%, this is highly significant because this value is greater than the table value. Now, if this is found to be significant here, we check that whether it is significant at the next level as well or no. And what is the next level?
And 0.001.
Yes, 99.9%, which is 0.001 probability. 0.001 probability. So the critical value or the table value at 0.001 is 0.266. And we can see that this value is also less than the calculated value. Calculated value is higher from the table value, even at the probability level of 0.01. So therefore, the result is very highly significant. right? So this result is very highly significant.
मैम ये दोबारा रिपीट कर दी, सिग्निफिकेंट एंड हाईली सिग्निफिकेंट वाला.
Okay. So what we are doing here is that we are checking for the null hypothesis to or no, right? So for that purpose, the first step is to check at the probability 0.05. So the acceptance or rejection of the null hypothesis is decided at this point, right? It is decided at this point that if the calculated value is greater than the table value, then we are going to reject the hypothesis in favor of alternative hypothesis. And we are going to say that the difference is significant, right? Alternative hypothesis was that the difference between the observed and the expected frequencies is significant. So there is no homogeneous distribution. So we have rejected the null hypothesis. यहाँ तक clear हो गया सबको? Is this point clear?
Yes, ma'am.
ठीक है? So if this point is clear, so it means that we have rejected the null hypothesis. Why? Because we found the difference between the observed and expected frequencies to be significant, right? We want to check it further, that whether this difference, that how much significant is this difference? Is it significant only at the 95% level, or is it more highly significant, right? Is it significant at higher level as well or no? यहाँ तक आपने डिसाइड कर लिया है कि नल हाइपोथेसिस रिजेक्ट हो गई है एंड द डिफरेंस इज सिग्निफिकेंट. अब आपने क्या चीज डिसाइड करनी है, दैट हाउ मच सिग्निफिकेंट इज दिस. ठीक है, ये सिर्फ इतना ही सिग्निफिकेंट है, इज इट significant, or is it highly significant, or is it very highly significant? अब क्लियर हुआ है पॉइंट?
Yes, ma'am.
Yes, ma'am.
So once you have found the value is significant, then you need to check at the upper levels, at the higher levels, that whether it is significant at those levels as well or no. And here in this example, you can see that this is significant at 9% as well, and it is significant at 99.99% as well. So this is really significant. So our null hypothesis is rejected, and it is rejected probability of 0.001, which is very highly significant. So the next step is to state the results. And how we are going to state the results? We are going to say that there is statistically very highly significant departure from homogeneity between the four categories. And then in the result statement, we have to give the test statistic, which is our calculated value, and the probability, right? The highest level of significance that we find. We have to state that significance level. So can you rephrase this sentence, this result statement?
मैम क्वेश्चन रिपीट कर दें.
रिपीट, आपको ये स्टेटमेंट समझ में आई है?
यस
Yes,
मैम,
ma'am.
आ गई.
आप किसी और तरह से फ्रेज कर सकते हैं, किसी और वर्ड्स में लिख सकते हैं स्टेटमेंट को.
मैम ऑब्जर्व्ड और एक्सपेक्टेड वैल्यूज इक्वल नहीं है.
Yes, you can say that there is a very highly significant difference, right? There is a very highly significant difference between the observed frequencies and the expected frequencies for homogeneous distribution. Or you can say that the observed frequencies very highly significantly differ from homogeneity. So there are different ways in which you can write down this result statement. but the good statement is going to be in which you are going to state that what is the maximum level of significance, right? So you have to state that this is very highly significant. And you have to mention that p-value as well here. And you can also say that the distribution of 4 species is not homogeneous in the population, right? The chi-square value is 19 and the p-value is 0.001, right? So this is another way to state. But the recommended way is that you must include this very highly significant phrase as well. ठीक है, आप ये भी include कर लें तो ज़्यादा अच्छा हो जाएगा. But you can write down in this way as well. You have already mentioned the p-value. Both are acceptable, both are correct. इनमें कोई mistake नहीं, ठीक है? Both of the statements are correct. इसमें कोई question?
मैम
जी.
मैम हमारी ऑब्जर्व फ्रीक्वेंसीज एक्सपेक्टेड के इक्वल आ रही थी, तो फिर हम लोगों ने अल्टरनेट हाइपोथेसिस क्यों यूज किया?
क्या चीज? आप
मैम
ये लिख
हमारी
के
जो
बता सकती हैं
ऑब्जर्व
क्योंकि आपकी आवाज में डिस्टॉर्शन आ रही है.
ओके
Our observed frequencies were equal to the expected ones? No, they were not equal to the expected one. Observed frequencies क्या थी आपकी? Observed frequencies were 24, 30, 10, and 9. And 24 is different from 18.75, 32 is also different, 10 is also different, 9 is also different. ये सब बहुत different है 18.75 से. The first one is 24. बाकी सब तो बहुत different है. Okay, so you were taking the total number of observations. Okay. So the number of observations should be same, right? Because we are calculating the number of observations from the, we are calculating the expected frequencies for the same number of classes and same number of observations that we have. इसीलिए आपकी वो तो obviously equal ही आनी है आपकी total number.